Okay, starting from now, we're going to learn a new chapter, a new thing called a system of equations and inequalities. And let's start with the easiest one. That is the systems, okay, of linear equations with in two variables. In two variables means x and y. So the system means system of linear equations. So system will be formed by different equations. And usually if you have two variables, then you have two equations. That's most of the time. It will look like this. Okay, see that this one shows it's a system, and we have 2x minus 7y equals negative 17. Okay, and I have a 3x plus 5y equals 17. So it looks like this. This is a very typical system of linear equations in two variables. And we need to find the value of x and y. That's a pair of number. And the x and y value, once you find, you can plug it back into both equations and they're good. So this is the job we're going to do for this section. Okay, there are three ways I'm going to teach you today how to do it. One is a graphical method, graphic, or we don't call that graphing method. I will do this later, but not many people use it. And second one, we call this substitution method. And then the other one is called elimination. Method. I'm going to go over these three methods one by one. All right, so the easiest one, let's do this. Let's do the substitution method. Okay, so substitute. You know what I'm going to do, right? So let me give you the example. 5x minus 4y equals 9, and x minus 2y equals negative 3. Let's look at this system. Look at those two equations first. Look at the coefficients, 5, negative 4, and here's a 9. And here's a 1, here's negative 2, here's a 3. Now, the good thing is you have a 1 here. Once you have a 1 here, you can rewrite that as x equals 2y minus 3. Can you do that? You plus 2y on both sides, so you're going to have just x on one side. Then you are going to, let me just use my other color. So once you have this, then you're going to substitute this x by 2y minus 3. Okay, remember you get this from this equation, right? Because that coefficient is 1. Then you get a simply x equals something, and then you plug it back. Now let's see what happened once you plug this back. You're going to have a 5 times, so that's a 5 times x. Instead of having x, I use a substitution method, so I substitute x by 2y minus 3. What are you doing? You substitute x by 2y minus 3, and you keep writing, copy the rest of this first equation. Did you notice there's no more x? The x is gone. How cool can that be? Okay, so we go ahead, we get a 10y minus 15 minus a 4y equals 9. All right, 10y minus 4y, that's a 6y. And for this negative 15, if I plus 15 on both sides, like the right side is 9 plus 15, I get 24. Okay, and then I go ahead, I find y equals 24 divided by 6, which is 4. Okay, so I get this. I get a y is 4, but not done yet. I need to find x. The good thing using substitution method is once you have this y equal to 6, you substitute back to here, then you can get x. Okay, so that will be x equals 2 times y right now is 4 minus 3. So that is 8 minus 3. The answer is 5. So you have x equals 5, y equals 4. So the way you write your answer is this, 5, comma 4. Okay, so that's your answer. That's your answer. X equals, or you can write x equals 5, y equals 4. Now, let's do this again. Let's take a look at this again. We have a system of equation, 2 variables, 2 equations, and we'll check the coefficients of those variables, and I found a 1 here. Then we just keep that. See, here's a 1, it's 1x. Then I just move everything to the other side. I get x equals something related to y. And then I substitute this x into another equation. So I dropped this variable. So x is gone because I use this as 2y minus 3. So I go ahead and I finished. I calculated and then I solved it. I get a y equals 4. And then because I already know that x equals 2y minus 3, I just bring back y equals 4. I get x. Or you can put y equals 4 back into any of the equation and solve it for x again. It's the same thing, but this is much easier because you already have this expression. What do you think? This is the substitution method. It's really nice, isn't it? Substitution. So substitution method that you should have at least one coefficient to be 1, then the rest will be easy. But sometimes you don't have that, okay? If you don't have that, and then you can use other method. But this is the first method I'm going to introduce, okay? The second method is called elimination method. Okay, what is the elimination method? That means I'm going to eliminate something. Basically, I'm going to eliminate one variable. Okay, how should I do that? Okay, so let's use the same formula. We use same system. So 5x minus 4y equals 9, and x minus 2y equals negative 3. Again, before I start doing that, I take a look at all those coefficients. Here's a 5, here's a negative 4, here's a 1, here's negative 2. Do you remember for the equation something equals something, the left side equals the right side? You can multiply by the same amount, by the same value, and it's still an equation. The reason I want to mention that is, can I use this second equation, multiply by a number on both sides? Then I will have one coefficient before either x or y, just the opposite of the other coefficient in the other equation. Because here's a negative 2. If I multiply by negative 2, I will get a positive 4. That's what I need. Here's a negative 4, so I will need a positive 4 here. So what I'm going to do is, look what I'm doing. I label my equations, all right? And then I will do the second equation multiplied by negative 2, which means the left side and the right side multiply by negative 2 at the same time. So multiply by negative 2, I get a negative 2x. Multiply by negative 2, I get a plus 4y. Negative 2, I get a 6. I call this as number 3 because that's a new equation. And then the first one, because I haven't changed that yet, I'm just write that here. And now you see why I want to do that. This is the first one, right? Okay, now you see why I want to make this negative 2, why I multiply by negative 2 in order to get a positive 4. Because I want to add these two equations together. So think about it. A equals a B and a C equals D. Therefore, A plus C equals A plus C equals B plus D. So I can plus. So 5x plus this negative 2x, I get 3x. Negative 4y, positive 4y is 0. What happened? I eliminate y. Okay, just by making the coefficient of y in both equations have just the opposite sign. You add them up, you're eliminating it. Okay, so y is gone. And then 9, 6, which is 15. Do you have it? Yes. 3x equals 15, x equals 5. It's very easy. And when x equals 5, you can bring it back to any of the equation and solve it to get a y. Okay, I'm not going to do that, but I want to show you another one, because this one, what I did is I use this one, I multiply by -2 so I can get a +4 and I add to it. What about if I use the whole second equation and multiply by -5? The reason I want to multiply by -5 because I want to add to this one, and that 5x and the -5x get cancelled. So the first equation is 5x minus 4y equals 9. Okay, and then I'm going to use the second equation, multiply by -5. Then I have -5x, here is a multiply by -5, which is +10y, and then -3, -5, which is 15. I add them up. 5x, -5x is gone. 10y, -4y, I got a 6y, and that is 24. Do you get a y? You get a y equals 4. Okay, so you can either do this or do this. You can either eliminate an x or you can eliminate a y. Eliminate an x, eliminate a y. But anyway, that's the general idea of that. This one, because we already have this coefficient 1, so it's not that, you don't see the big benefit of it. Sometimes you cannot say, hey, this one is 1, so I'm just use the substitution method. Perfect, no problem. But what happens if here is 8? Then it's not that obvious. It's not easy to use the substitution method. So it's much easier to use elimination method, isn't it? Sometimes you might want to multiply by the first equation, multiply by a number, and the second equation you have to multiply by another number, just to make them one variable to have an opposite sign. All right, so this is the general idea about the substitution method and the elimination method. What about a graphing method? Graphing method. Okay, so we have 5x minus 4y equals 9. We have x minus 2y equals -3. I will graph these two lines in my system. Where was my system? Okay, to the coordinate plane. And then if you have two lines, and where they're going to cross each other, and that is your solution. And that x, y coordinates are your answer. That's your answer. So in order to graph 5x minus 4y equals 9, I will choose some x value and choose some y value, okay? So I know 5 plus 4 is 9, so that's when x equals 1, y equals -1, and that will do, right? So that's 5 plus 4 is 9, so I already get 1 point. And then the other point, I can put x equals 0, so this is a 0, then y will be -9 over 4, or -2.25. So once you have a system, this is x 0, 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5, that's y. Okay, so I have a 1, -1, which is this point, and I have a 0, x equals 0, and y is -2 point, that's -3, it's right here. I can graph it. Once I have 2 points, then I can connect them and I can graph. So this one is actually 5x minus 4y equals 9. Okay? And then let me graph the other one. X minus 2y equals -3. Okay, so I have x, I have a y. I can choose y to be 0. That's easy. So this part is 0. Then x will be -3. Okay, so I can choose y equals 1. When y equals 1, Here's negative 2. This got to be negative 1. So negative 1 minus 2. So I get 2 points. So what next is negative 3, 0. That's 1 point. And the negative 1, 1. That's another point. Did you see that? This is the graph x minus 2y equals negative 3. I don't put here, I put here. So this is 5x minus 4y equals 9. Do you see where they're going to cross each other? Where is the solution? It's not a very good graph, okay? Because it's not very accurate. Basically, if you can graph very, very accurately, your answer is 5, 4. So that's 5, 4. It should be here. I'm so sorry, but it's not. Okay, you get the idea. That is why usually we don't use the graphing method unless you are very good at a drawing graph. Okay. So, this is using the graphing method. The good thing about this solution, to find the solution of this system of linear equations, the best part is this. Once you have the solution, once you have the x and y, what you can do is you can bring your x and y back to your equation. You can check your answer. So before you submit it, you already know whether you get the right answer or not. Okay? Is that interesting? That's good for you, right? All right, now let's work on one more. 2x minus 3y equals 4. And 4x minus 6y equals 8. What do you think? These two are identical. Because if you use this one, the first equation, if you multiply by 2, you get the second equation. Which means when you graph them, you get exactly the same line. So what does that mean? If you graph, you get the line, this is the line 1, and this is the line 2. So how many solutions there? You're going to say there are infinitely, because every single point on that line are solutions. So there are infinitely many solutions. Okay, because they're the same line, and at any point on either line, that would be your solution. Okay, so this equals this. What about the other one? What about 2x minus 3y equals 4, and the other one? Okay, 4x minus 6y equals 18. So if you multiply this by 2, you're going to get a 4x minus 6y equals 8, right? That's the first one. And the second one says it's 18. Is that possible? Can 4x minus 6y be both 8 and 18? Which is impossible. That means no solution. What does that mean? That means if you graph these two lines, you get two parallel lines. And that makes sense because these two parallel lines, they're not going to touch each other. They just keep going and going and going, and there's no solution because there's two equations, they're conflicting. So that's the parallel lines. All right, so that's pretty much you need to know the system of equations with two variables. And also we learned 3 methods. The graphing method, pretty much the one you don't want to use. And the second one is the elimination and the substitution and elimination. We use this two quite a lot. Okay, at the end, I'm going to give you another example, which is a very traditional Chinese math problem. Okay. All right, now the question is, if there are altogether chickens and rabbits, total there are 35 of them, 35 chickens and rabbits, okay, in on a farm, and they have altogether, they have 94 total legs. You know, chickens have 2 legs and the rabbits have 4. So the question is, how many chicken and how many rabbits? Can you do that? Find how many. All right, now we just assume there are X chicken and there are Y rabbits. Chickens and rabbits, okay? So if their total is 35, what do we know is X plus Y should be 35. That's when we count their head, okay? And what about the legs? For X chicken, how many legs? 2X legs. And for rabbits, 4Y, that many legs from rabbits, and altogether is 94. See, you get this system of the system of equations. Can you go ahead and solve it? Yeah. You want to use the substitution or you want to use elimination? Let me do both. Okay. So if we notice here is 1, here's 1, so we can just choose either one. So I choose X. So I use the substitution method. So that X will become negative Y plus 35. And then I'm going to substitute here. So that becomes 2 times, instead of having X, I write negative Y plus 35. Okay, and then I go plus 4Y equals 94. Okay, I go ahead, I get a negative 2Y plus 70 plus 4Y equals 94. Negative 2Y, positive 4Y, I get a 2Y. And then I subtract 70 on both sides. 94 minus 70, I get a 24, so I get a Y equals 12. That is 12 rabbits. Okay, and once you have this Y equals 12, you bring it here. Negative 12 plus 35, so your X is 23 chicken. Okay, so your answer is 23, 12. Is that right? Do they add up to 35? Yes. So 23 chickens, total is 46 legs, and 12 rabbits, so that's 48 legs, and altogether that's 94 legs. So that's right. Okay, so this is the substitution method. If you want to use the elimination method, you can use the first one. You multiply by negative 2 and then add to the second one. So you get a negative 2x, negative 2y equals negative 70. You see what I'm doing? I use the first equation and multiply by negative 2. And then I copy the second, 2x plus 4y equals 94. And then I add them up. So I'm using the elimination method because I want to get here canceled, and I get a 2y equals 24. So I get a y equals 12. And once you have a y equals 12, you can bring back to either equation y equals 12. Then you can also get x equals 23. So either method, you should get exactly the same answer. But this is a very fun question, I think, because I remember when I was little, my mom asked me to do this type of question. Without writing the equation, of course, when I grow up, I know that you can set up the equation to solve for it. And when I was little, I have to think and figure out how to do it. And if you like, I can tell you how do I think and how do I solve this equation. But basically, this is everything for the system of equations with the two linear equations with the two variables. Okay.